to simplify this principle, which rocket propulsion depends on, let's make this activity. If we have a balloon like this one, and this balloon filled with air, so if you just release the balloon, the air goes down in this direction, and the sorry okay in this direction, and the balloon goes up as a reaction of the action of the air. So this the rule of Newton's third law, if you remember, which we studied it before. So we can also apply this on the rocket to determine how rocket propulsion work. The burning gas inside the engine of the rocket, okay, go down, and the thrust force push the rocket to go up. Okay, so rocket propulsion depends on two physical principles. The first one, which we agreed on it, Newton's third law. The second one, conservation of linear momentum, and we gonna to explain how. And okay, later we're gonna to explain this later. So when the rocket propulsion is launched, it goes through several stages. Okay, let me draw this for you. The rocket starts from its station from here, like that. Okay, this is the rocket. Okay, at the first stage, the rocket go in this way. At the second stage, the rocket go. Okay, what you need to know, every stage the rocket separate part from it. Why? To reduce the mass, which reduce the required energy. Okay, which reduce the required energy. And also, as you see, the rocket designed pointed. Why? To reduce the friction between the rocket and the air. So rocket also work best outside the atmosphere or at the space in general. Why? Because there are no air, so there are no air friction, and the action and reaction occurs inside the rocket's engine. Okay, now what the relation between the rocket and the between the impulse and the linear momentum? Let's see. If you remember the okay, if you remember the Newton's second law, which said F equal ma, m for mass and a for acceleration. And also, if you remember the rule of acceleration, which said acceleration equal the change in velocity, which we said Vf minus v naught over time. And the rule of impulse was impulse equal force by the time. The last thing which we studied in the last session, the rule of momentum, which we say B equal mv. Now let's apply all of this to understand how is the relation between impulse and linear momentum. So I'm going to start from this equation number 1. Okay, F equal ma. So by substituting the value of a inside this equation, so F gonna to be equal m time v final minus v naught over time. Okay, now we're gonna to substitute all of this here in equation number 3, for example. So I equal f t. I'm gonna to substitute this value by the f. Okay, so impulse equal m vf minus v naught over t time t. Now we can remove t with t to have impulse equal m time v f minus v naught. Okay, now by make multiplication between the two terms like that, so it's going to be impulse equal m v f minus m v naught, and we already know from this rule that m times v is the momentum, so impulse equal b, the final momentum, minus the initial momentum. So okay, I will continue here in this box. Okay, because when the rocket gonna to launch, it's b at rest. For that, b initial gonna to be 0, so the impulse equal the momentum. Okay, you have to save this equation. Also you have to know, okay, let me write this outside. Okay, this is the relation between the impulse and momentum. Impulse equal the momentum, and also the unit of impulse equal the unit of momentum. We discover that the unit of momentum is, okay, unit of momentum is kilogram time meter per second. So here kilogram time meter per second, so impulse also would be kilogram time meter per second, or due to the impulse is the product of, as we said, the force and time, so we can also give this unit to be Newton time the time. Okay, now let's talk about the final equation was impulse equal momentum. So we can say the momentum of the rocket, okay, momentum of the rocket, okay, r equal the momentum of the gases, okay. So m plus, which equal f time t, equal mr mass of rocket time vr mass of velocity of rocket, equal mg mass of gas time vg velocity of gas. And we can put this sign here to describe the direction, because when the rocket go up, the gases go down, okay. This sign just to describe the direction. When we solve any question, we remove it, okay. Okay, this rule you have to memorize it. There are a lot of questions. We gonna to use this rule to solve it. And also you have to know the force of rising the rocket. Maybe we say it force of rising the rocket, force RR for example, equal the force of engine minus the weight of the rocket, which the weight, as you know, weight equal mass time the acceleration or time the gravity, okay. Sometimes you're gonna to use this relation to find the force of rising rocket, okay. There are a difference between the force of engine, this is the force of engine, and this is the force of rising the rocket. Because if we say here is the rocket and this is, okay, the gases, so when the rocket or when the engine, here is the engine of the rocket, and this engine has a certain number of force, so but because there are a weight of this rocket, okay, this weight acts on this direction, so this weight will reduce the force of engine by the value of the weight of the rocket, okay. So sometimes we need this relation to find the force of raising the rocket, okay. Okay, now let's back and answer this question. Okay, the question say a rocket gets hot gases from its engine with average of 1300 kilograms. So this is the mass of gases equal 1300 kilogram, okay. And the particles velocity, so the rocket was 50 times 10 power 3 meter per second, okay. And this is the velocity of gases, Vg, equal 550 times 10 power 3 meter per second. So what is the force of thrust? Okay, we're looking for F, the force of the engine. So we agreed that on this relation that we said, Okay, let me write it. F T, F time T equal M of rocket times V of rocket equal negative M of gas times V of gas. Okay, so now I'm going to use this one and this one because I have already the both value of here of gases, and I have the time in 1 second, as you see, in 1 second, so I can calculate the force. So the force equal engine equal, okay, as we see this negative sign just to determine the direction, mg time vg over the time. Okay, mg is 1300, time is 1 second, and vg is time 50 time 10 power 3. Okay, by using calculator the answer is 65 time 10 power 6. Okay, this is force, so the unit will going to be Newton. Okay, and the second question is what is the velocity of the rocket. Okay, now we're looking for the velocity of the rocket, so we're looking for VR. Okay, now we're going to use this to find the VR. Okay, MR VR equal, for example, we already got the force of the engine, we can write this value. Okay, so VR equal F over MR, so 65 times 10 times 10 power 6 over the mass of the rocket, 10 times 10 power 3. The result will be equal, okay, 65 times 10, sorry, 65 times 10 power 2, and the unit of the velocity is meter per second. Okay, this is was the answer of this question. Okay, the next question is very easy, I will let it for you. So here is a good note. Always you gonna to find the velocity of the rocket is smaller than the velocity of the gases. Here the velocity is of gases 50,000 and the velocity of the rocket 6,500. So, and this show to us why, because as we said, the momentum of the rocket equal the momentum of gases. So because the mass of the rocket always so much greater than the mass of the gases. Okay, for that always gases have a greatest velocity, a so much greatest velocity than the rocket.